And liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Control program. Challenger, go with throttle up.
On January 28, 1986, the Space Shuttle Challenger exploded 73 seconds after liftoff, killing all 7 people on board. An investigation into the accident uncovered a history of risky decision-making and cultural deviance within NASA, brought about by the pressures to meet the ambitious and unrealistic goals on which the Space Shuttle program was founded. Despite the tragedy, NASA recovered and administered the improvement of spaceflight safety and organization. The Space Shuttle program triumphantly went on to achieve many of its original goals by launching frequent flights and deploying impactful technology for the modern world. Today, the Space Shuttle Challenger accident serves as a reminder and a lesson of the tragic outcome when pressures provoke risky organizational practices. During the 1950s and 60s, the National Aeronautics and Space Administration, NASA, successfully oversaw the Mercury, Gemini, and Apollo programs, which launched some of the first men into orbit and landed the first men on the moon in 1969. During the Apollo program, NASA consumed around 4% of the national budget, allowing the United States to achieve the ambitious goal of a moon landing. However, in the 1970s, spaceflight funding was reduced to accommodate programs such as health, education, and defense. NASA's future was threatened by impending budget and personnel cuts. Therefore, in order to garner economic support, post-Apollo NASA opted for a more profitable direction, emphasizing the development of space application technology and the construction of a routine and economical access to space. Out of these goals came the Space Transportation System, also known as the Space Shuttle. The Space Shuttle program was supposed to reduce the operating costs of launching by being fully reusable, making space travel more routine. It would also transport government and commercial payloads to orbit for profit. However, its $10 to $13 billion price tag was astronomical, and budget constraints required compromises to be made between cost and design. So the shuttle was redesigned to be partially reusable, resulting in an initial budget of $4 to $5 billion, but postponing the majority of the cost for the operational phase of the program. The Space Shuttle design was finalized in 1972. It would comprise of 3 components: an orbiter to house the crew and payloads, a non-reusable external tank, and 2 solid rocket boosters that provided the majority of the thrust during launch. On April 12, 1981, the Space Shuttle made its debut. After 3 more missions, the Space Shuttle was declared operational, accelerating the flight rate and the cost of the program and initiating its main phase. From 1981 to 1986, the Space Shuttle hauled commercial and government payloads into orbit, and its crews conducted various experiments concerning fluid dynamics, microgravity, and biology. During this period, the frequency of shuttle flights ranged from once to even twice a month. This era of spaceflight, however, was soon to come to an end.
It was, I could say a highlight of our lives. So it went from being a very, very happy, upbeat occasion to a very difficult, sad time.
The launch of the Space Shuttle Challenger on January 28, 1986, occurred in the coldest temperature in which a shuttle was ever launched, 36 degrees Fahrenheit. The beginning of the launch appeared to be normal until 73 seconds in, when the external tank erupted and destroyed the orbiter. All on board were killed, including teacher Krista McAuliffe, who was supposed to deliver lessons to students from space. President Ronald Reagan responded to the accident by establishing a presidential commission chaired by former Secretary of State William P. Rogers to investigate the accident's causes.
Every time something like that happens, we take a look at how we do business. You want to take a look at your procedures. What caused this accident? What could we have done to prevent it?
During the spring of 1986, the Commission conducted hearings and investigations into the accident, in which they uncovered a history of risky decision-making within the Space Shuttle program. While reviewing footage, the Commission discovered black smoke spewing from one of the solid rocket booster joints. It was determined that the 2 rubber O-rings that were meant to seal the joints of the multi-segmented boosters had not expanded in the cold temperature and had allowed hot gases to leak through. These gases burnt through the strut connecting the booster and the external tank, which triggered an explosion. The testimony of the hearings revealed that, on the night before the launch, a group of engineers from Morton Thiokol, the contractor company that built the solid rocket boosters, held a teleconference with NASA to discuss the safety of the O-rings. These O-rings were a component that historically had many issues with allowing more leaks as temperatures grew colder. Although Morton Thiokol engineers initially recommended against launch, NASA officials persuaded them to reconsider, and Morton Thiokol gave the go-ahead.
And NASA changed its philosophy or its paradigm from prove it's safe or we're not going to prove it's not safe or we are going. And that's a tremendously dangerous paradigm to assume.
Why would NASA go on with launching, despite warnings of the dangers of cold temperature on O-ring performance? The O-ring problem was an issue familiar to many missions during the Shuttle program from 1981 to 1986, occurring on 90% of the missions in 1985. With limited funds, NASA had to gut its own safety facilities to keep up with an operational schedule of preparing for launches and conducting regular maintenance. As critical problems like the O-ring began to recur on missions with little consequence, they became institutionalized as acceptable risks. The schedule and economic pressure of the Space Shuttle program caused NASA to focus on meeting deadlines rather than safety guidelines and led to the normalization of deviance. On June 6, 1986, the Presidential Commission submitted its report, citing the O-ring as the catalyst for the accident and NASA's risky culture for allowing the O-ring problem to persist. The Commission provided recommendations for the Shuttle program on the improvement of the O-ring design, the management structure, the flight rate, and the processing of critical or broken hardware. Most importantly, NASA established the Office of Safety, Reliability, and Quality Assurance with the job of documenting and analyzing flight anomalies. Even with the tragedy and loss of the accident, the Challenger disaster temporarily led to the improvement of spaceflight safety. After the resumption of shuttle flight with the launch of the Shuttle Discovery on September 29, 1988, NASA embarked on a highly successful period of spaceflight. In 1990, NASA deployed the Hubble Space Telescope, which is returning imagery of the distant corners of our universe to this day, leading to important astronomical discoveries. In addition to Hubble, the Space Shuttle was used to carry many commercial satellites into orbit, drastically improving our weather forecasting technology and satellite communications, and establishing a technologically interconnected world. The shuttle also transported pieces of the International Space Station, an orbiting laboratory and habitat for astronauts from 18 different nations, that is presently a global symbol for unity in space. Regardless of all the initial improvements within NASA, the persistence of pressures to perform and meet their original shuttle goals provoked the loss of the Space Shuttle Columbia and its crew in 2003. The Accident Investigation Board of Columbia revealed that a similar risky culture in NASA led to the accident, with the negligence of recurring foam debris issues that fatally damaged the shuttle. The greatest tragedy of the Challenger accident is that despite its warnings, NASA reverted to the same risky and pressured environment. This is because, while restructuring parts of NASA's culture, the Commission did not identify the underlying issue of the accident. This issue is the coexistence of severe budgetary constraints on an experimental program and the pressures to perform that is inherent to the competitive NASA culture. Nowadays, the Challenger disaster provides a case study of production pressures and organizational deviance in the manufacturing and technological worlds, and is used by professors and authors to teach proper ethical procedure in these fields. The impact of Columbia and Challenger on the NASA culture has shaped a more cautious environment that appropriately acts with its limited resources. The steps NASA has taken to correct its environment are a triumphant example of the positive impact that tragedy can generate. The technological and scientific triumph of the shuttle program for the modern world alleviates the loss of Columbia and Challenger, with its reshaping of our understanding of the universe that we live in. On January 28, 1986, after the accident, President Ronald Reagan spoke these words to the nation to honor the astronauts that lost their lives that day.
The crew of the Space Shuttle Challenger honored us for the manner in which they lived their lives. We will never forget them, nor the last time we saw them this morning, as they prepared for their journey and waved goodbye, and slipped the surly bonds of Earth to touch the face of God.